Hello everyone, welcome back to the channel. I hope you guys are doing really well. So let's see today's daily challenge on Leetcode and we will solve it together. So today's challenge is a quite interesting one. Increment submatrices by 1. Uh, if you are given a positive integer n, okay, you are given a positive integer n here, and it indicates that initially we have an n cross n zero index integer matrix filled with zeros. You are also given a 2D integer array query, and for each query I you are given 4 values. What are those 4 values? It's row 1, column 1, row 2 and column 2. What should you do? Add 1 to every element in the submatrix with the top left corner as row 1 column 1 and bottom right corner as row 2 column 2. That is, add 1 to matrix xy for all x and y. Okay, so return the matrix after performing every query. You can easily see this example. The first query, its n is 3, it means that you have a 3 cross 3 matrix of all zeros initially present. Okay, and after that the first query starts with 1 comma 1 and 2 comma 2. So it means that top left corner of the updation matrix is 1 comma 1, which is nothing but this. Okay, which is nothing but this middle element, and 2 comma 2 is nothing but this last element, which is the bottom right. So among all these values you need to increment by 1, and 0 0 1 1 means 0 0 is the top of the second updation matrix. Top left is 0 0 and bottom right is 1 1. So if you again update all elements in this matrix, you will get something like this, and this is the final output matrix which you need to print. Okay, so that's what. So I hope you do get it right. In case you did not get, I will just quickly tell you what was happening in that example. So basically you were given an initial matrix to be something 3 cross 3 like this, and your first query was update this whole matrix. Okay, so how was the query given? The query was given in the form of this top left and bottom right. Okay, so top left is nothing but 1 comma 1 and bottom right is nothing but 2 comma 2. So in the query it was 1 comma 1 comma 2 comma 2. Okay, I hope you do get that. And yeah, so we do take this and update all of these elements. So what will happen after I update these elements? It will be 1. In every updation I increment by 1, and in the next operation what they do is increment this by following similar query, increment this whole thing, and you can already see that after incrementing that what the result will be. It will be something like 1 1 2 1. Okay, so like this, and this will be your final matrix which you need to output. Okay, so I hope the approach is at least not the approach, at least the idea is clear to you very much, that what you need to do in the problem. And if you try to see, you cannot brute force it out obviously, because queries is 1e4. Okay, so 1e4. So if you see, 1e4 is the number of queries, and 500 is the number of n. Okay, so for every operation if you try to use n square, it will be something like 1e5. Okay, if you for every operation if you try to use n square, it will be 1e5, and are given 1e4 such operations. So definitely you cannot do 1e9, O of 1e9, it will give you a TLE. So definitely doing the brute force approach doesn't work here. It's quite obvious, you need to think something better. Now this here comes an idea of difference array or line sweep. So for understanding, if you are not aware of this kind of techniques, what we do is that after you understood that there is a 2D array in this problem and you need to update a subset of that every time, let's try to think what will happen in case of an 1D array. So let's say initially we are given a 1D array something like this, and we are given ranges of which we need to update. Okay, so let's say our first updation tells me that hey, update these 3 elements. Okay, so you will get something like this. Okay, and then again it tells you that hey, now go and update these 2 elements only. So you will go and update these 2. Now let's say if not the last one. Now let's say if it tells you update all of these elements, you will go and update something like this. Okay, I hope you do get it, how you are going to update stuffs. And I hope it is clear how we can visualize the 1D array case. And for 1D array there is a technique. I hope this is used in many problems, and I have told in my previous video also, some of the my previous video, line sweep or difference array technique. Okay, so if you are not already aware of this, I will just tell you how it happens for 1D array case, and I will extend it to also explain the 2D array example. Okay, so what happens exactly is that let's say I am going to perform this thing. So what is the query which is given here? So if you try to see what will be the query which is given here, it will tell you that update from index number 1 to index number 3, right? So 1 comma 3 will be the query here, and it will tell you update the index number 3 to 4 inclusive of both ranges, update index number of something like 2, 3, 4, 5, 2 to 5. Okay, so these will be the queries which are will be given to you. Okay, this is the first query, this is the second query, and this is the third one. So what will you do in such a case is that you prepare a array which tells you the which tells you at what point it is starting and ending. Okay, only the starting and ending values it stores. So basically you take a vector of zeros initially, and then what you do is that you go at index 1 and increment that 0 to 1. Okay, and then you go to index 3, the next element after index 3, and do a minus 1 over here. Okay, so what did you do exactly? Let's say there are 6 elements in this array, right? So in my difference array I will try to take 7 elements. Okay, so what I am doing right now is 1 and 3. So this is index 1 and this is index 3, right? So in 1 I am incrementing 1. Okay, and in 3 plus 1, in just the next element after 3. So this is not 3, right? I hope you do understand. This is 3, 1 and 3. So in 1 I increment 1, and the element just after 3 I did do a minus 1. What exactly I am trying to do here? You see, first observe and then I will tell you. Okay, so I process one query 1 comma 3, and then comes the query of 3 comma 4. Okay, so you see 3 comma 4. So I will start with 3. So this is the index number 3. So I will increment that by 1, and I will go to 4. So this is the fourth element. So after fourth element I will decrement that one. So basically it tells me that hey, there is a range which is starting at this point and ending at this point. Start is denoted by +1 and ending is denoted by -1. Okay, that is what we are trying to do. So after processing the last query, you see 2 comma 5, right? So if you try to see the index number, this is the index number 2, right? So I will increment this 2 comma 5. So this is my fifth index, so I will decrement this value. Okay, so minus 1. So I hope you do get to understand what I am trying to do. Then I will calculate the prefix of this prefix sum, the whole prefix sum of this difference array. I hope you at least know what is a prefix sum. If you don't, just Google it out. Yeah, so you just add these two elements and then add all these elements to get 2, add all these elements to get 3, then add all this element to get 2 again, then add all this element to get 1 again. Yeah, so you have it, and that's all. You have this 0 also with you, but you truncate this value off because your initial value was only 6. Okay, so this is how optimally you could have done for a 1D array, and I hope you do understand what I'm trying to do. You see these answers exactly match. Okay, these answers are exactly matching, and what we need to do and how we visualize this is that you are giving a starting and ending point. So one acts as a start of flow. So you imagine water is flowing. Okay, so this is just an analogy. You imagine a water of ones is flowing from here, from this point. So when you place a 1, it means that since you are calculating prefix sum, this 1 will be added to every element which is there after it. Okay, so you just add 1 1 1 1 like this. There is a flow of 1, you can say that there is a flow of 1. Okay, now flow of 1 is towards the right. You see, whenever you place a -1, there is a flow of -1 from here. So basically what it does is that if you start a flow of -1 from this point, it just tells you that, hey, stop the flow of 1. Basically, if you start a flow of -1, it will extinguish all of these ones. Okay, so it tells you that stop -1, basically tells you that stop flow of 1. Okay, that's what it tells you. And similarly, if you try to place another one over here, you are telling that from index number 3 there is another flow of 1. So from index number 3 you try to do another flow of 1, this one will change to 2 now, and this will be 1 1 1. Okay, and again if you try to stop the flow of 1 with this -1. Okay, so with this -1 you again stop this flow of 1. Okay, so that's what you just add all the flows using the prefix array. The flows, the summation of all the flows are taken care of using the prefix array in just O of n time, and you process the queries, each of the queries you process in O of 1 time. That's what you do in a 1D array. Okay, now comes the portion for 2D array. Okay, so for 1D array you will assuming that once I place a 1, the prefix array will calculate will add this 1 towards the right. So there is a flow of 1 and I use a -1 to stop that flow of 1. Okay, and similarly there can be a flow of 1. If two flow of 1s overlaps, they will form 2. Okay, you will start forming 2. So that's how it was proceeding for 1D array. For 2D array, you see what we do is that there will be a flow of rectangle. Okay, so once you place a 1 at any point, imagine that there will be a flow of 1 to the right, flow of 1 to the left, downwards, and flow of 1 everywhere. So what do I mean by everywhere? It means that in the bottom right portion of the whole rectangle there will be a flow of 1. Okay, in all of the directions there will be a flow of 1. So it means that this whole bottom quadrant, okay, quadrant 4 you can tell, that is filled with 1s once you put a 1. Okay, so what will happen when you try to update a matrix using all these coordinates? What will you do exactly? See, you need to stop this flow of 1 to the right. Okay, you need a -1 for that. You need to stop the flow of 1. So let's say you are only updating this portion in the matrix, right? You are only interested in updating this portion. So first of all, in the top left portion you place a 1, it will give a flow of 1 everywhere. Then in this portion you place a -1, it will give a flow of -1 starting from this point. So that will extinguish all of these ones. Okay, now if you place a -1 at this point also, it will stop the execution. So -1 should be placed. So if you want to place this 3 cross 3, -1 should be placed after that, right? So it will stop the flow of ones again in the bottom direction. Okay, in all these directions. But if you see, these two -1 get overlapped in this region. I hope you are understanding what I am trying to say. So here placing a number means that number will get flow of in all the directions over in whole of this matrix. So basically if you place a 1 over here, it gets flows of everywhere. So and now if you place a -1 over here, the flow of -1 is stopped in this direction. The flow of -1 is also stopped in this direction. But if you notice, there is an overlapping region here. Flow of -1, here there are two -1s present. So you place a +1 over here in order to make this also whole as -1, because this whole thing with -1 only you can stop a +1 flow. You cannot stop a +1 flow with -2, because that will be negative flow, right? So you place a -1 over here. So basically I hope you do get to understand what I am trying to do. For 2D array, for 2D array case, what I do is that if I am given 4 coordinates. I am given 2 coordinates, right? The top right and bottom left, bottom right and top left. Okay, so if you are, let's say, given this one as r1 comma c1, right, and this point you are given, let's say, as r2 comma c2. So this point is r2 comma c2, I will say. So you, what do? You go to r2 plus 1 comma c1. You go to r what is the value of this? You go to r1 comma c2 plus 1. Okay, you stay in the same row and go to r1 comma c2 plus 1, and you also go to r2 plus 1 comma c2 plus 1. So what do you need to do? What are all the things you need to do? You see, array of r1 c1, you add a plus 1 to it, plus equals to 1. Okay, array of, what do you do for this? r2 plus 1 c1, what do? You do a minus minus for this. Array of r1 c2 plus 1, you do again a minus minus for this. I hope you are understanding why I am doing, right? And r2 plus 1 c2 plus 1, you do a plus plus for this. So 2 times plus plus and 2 times minus minus, if you do this and just calculate the prefix array 2 times, it will just give you the answer. Okay, there is nothing much thought process about this. So yeah, I have it, and let's start to code. It will not be very difficult. So if I do something like vector of vector integer and array, and I will start my array as n plus 1, right, and vector of, again it will be an integer, and again it will be n plus 1, and if I do nothing, it means that everything is initialized with 0 initially. And now I am also having the queries, so I need to process the queries. I will do auto @q queries. Okay, so what will happen with this? I will have r1 c1 everything ready, so r1 will be nothing but q of 0, c1 will be nothing but q of 1, c2 will be r2 will be nothing but q of 2, they are in order, right, and c2 will be nothing but q of 3. So r1 comma c1 is the top left coordinate, and r2 comma c2 is the bottom right coordinate. And as I told you, r1 c1, basically r1 c1 will be just plus plus, and array of what are all the things, r2 plus 1 c1, so r2 plus 1 c1 will be minus minus, array of c r1 and c2 plus 1 will be minus minus, array of r2 plus 1 and c2 plus 1 will be plus plus. Okay, so these are all the 4 coordinates, which are these are all the 4 coordinates which basically gives me this exact matrix which I need to calculate. And yeah, this is the difference array which I need to do. And yeah, now just in the same way we calculate prefix sum for a 1D array. Okay, so for 1D array we calculate prefix sum in one direction. So for 2D array we will calculate the prefix sum in both directions. Okay, no special formula or nothing we can use. We can just simply, what we can do, y n or j will start from 1, j plus plus, and what will you do in such a case? Array of ij will be nothing but array of ij minus 1. I hope that is very simple. I guess there is no difficulty in at least understanding these statements. And yeah, I can do the same way with j, and this time I will do for I. Okay, so ij plus equals to I minus 1j. Okay, so that's what. And yeah, see, now I have an n cross n, n plus 1 cross n plus 1, but my initial array which I need to return is n cross n. So similarly, what we did in a 2D array case, we truncate of this. Okay, so what we do for 2D array, you see, we have an extra dimension, we need only this portion, right? So we can truncate off this whole portions, right? So how do we do that? We first truncate off the last row and then we iterate through the rows and truncate off the last column. That's what we can do easily. So what we can do, array dot pop back, okay, just simply truncates the last row, and this I can do very simply. Okay, so for this it will be array of I dot pop back, just truncate the last elements and you can simply return an answer array. Yeah, that will be all. If you try to submit it, it should work just fine. Yeah, you see we got the accepted thing. If you try to submit, I hope it will work for all test cases without any errors. And I don't think we use much time complexity, we are simply using O of n square here, and yeah, n will definitely, if it is in the range of 500, so definitely it will work. And yeah, so here we use Q queries, we process all of them in O of 1 time. So basically O of 4 time you can tell, which is nothing but O of 1. So overall time complexity will be simply O of n square. It's O of n square only, but you can add O of n square plus 4q, you can tell. Okay, so yeah, whatever be the case, I hope that works, and that also gives a good runtime complexity. You see over here, yeah, n square plus q, you can do it, n square plus q, they are omitting this 4. So yeah, that's all, I guess that's all for this video. I hope you do understand what is the approach of this problem. And yeah, I will meet you in the next video. Till then, thanks a lot.